In this video, we're going to go over some considerations for using a LiDAR-derived DEM. We'll be introducing concepts such as hydromodification of DEMs and some pre-processing that you should do on your DEM before conducting any sort of flow modeling across the landscape. When you download your DEM, it's very important to go and look at the metadata to see what, if any, pre-processing has been performed on that DEM. For example, here I'm showing you hydroflattening, which is generally performed by the vendor who is collecting the LiDAR. Hydroflattening is what is done to flatten elevations within water bodies and wide rivers. This is done because LiDAR is not collected over water. The pulse that is sent out is actually absorbed by the water instead of returned back to the sensor like it is over landforms. So, since there is no data, the water surface is interpolated using the bank elevation, which creates ridges as shown there in that left side image there. And these ridges can act as dams, which will impede flow. So, in these lakes or water bodies and wide rivers, we flatten them, which smooths the surface, and then also a constant downhill gradient is created, which you can imagine this would be important in things like rivers. A second process that can be done in your DEM is hydro enforcement, which is where obstructions to flow are cut through a DEM that allow the water to continually move through. See, in this example here, we have roadways that would have naturally impeded the flow based on the LiDAR because it's seen as a dam, but now it's been cut through, which allows the water to flow on through. This is not likely to have been done by the vendor. It's a very detailed and time-consumptive process. However, it's extremely necessary to produce an accurate flow model and therefore an accurate watershed planning model. So to give an example as to why hydro enforcement is so important, you can see below an example of where a cut line has not been made through this road. So you have your flow path, and when you do terrain processing and get a raster out, like a flow direction or flow accumulation raster, when you're above that road, everything's moving along fine. It hits that roadway, treats it as a dam, so that flow begins to back up behind there and creating a ponding effect until it reaches such a height that it can spill over that roadway. And when that happens, the flow path no longer is falling into the correct channel, and we get this skating rink effect, which you can see in the lower image there. So it's extremely important to make cuts where you know they are and you can see them in imagery and say your hill shade, because you want your flow paths to fall within the actual channel, not just spilling over all over the place like we can see in that lower image with those white lines. In this example, you can see these depressions where water is been backing up against these roads because no cut lines have been made, and therefore flow paths are inaccurate or flow accumulation values are wildly inaccurate. And it's just basically reinforcing why it's important to make these hydro modifications in your DEM so that you can have accurate flow paths and therefore accurate watershed models and accurate placement of agricultural conservation practices, which is the whole point of this. We want accuracy so we can suggest good results to our watershed planners. And the ACPF has been built to really assist you in this process of hydro conditioning. And we have some tools that we've developed that will guide you step by step through this process. There are three tools involved in the hydro conditioning process. The first one is the Identify Impeded Flow tool, the second, Visualize Flow Path, and the third, the Manual Cutter and Dam Builder. These three will be ran iteratively to create an accurately hydro conditioned DEM. It's extremely important that you take your time and are diligent through this process. If you don't take your time or you skip steps, you're going to lack an accurate flow network. And in return, you're also going to have inaccurate conservation practice placements down the road. Here's a brief recap on the intro to hydro conditioning.